Hi guys, I am Jason Janjidoke from Bisid Matoe. So today we will be discuss the transportation problem using northwest corner method, least cost method, Vogel's approximation method, Moody method. So let's go. So our first step, we will be start in this area, in this cell, because this is a northwest corner method. So we must see the supply. Our first supply is 550 and the demand was 250. So this will be the 250 will be the our allocated cell. So this is will be 250 in this area. So since the 250 is satisfied and this entire column will be cancelled out. So this will be 0 and the 550 will be subtract 250 and this will be now 300. So our second step, so we put this and this will be the free cells. So we will be moved to this cell and this cell. So our supply is 300 and the demand was 400. Since the 300 was the lesser value, so we will put the 300 here in this cell. So this 300 will be cancelled and the entire row will be cancelled out. And this 400 will be minus 300, so this will be 100. So our next step, our next cell is this area. So this will be our third cell. So since our value of the supply is 275 and the value of our demand is 100, so this will be our 100 hour be put in the allocation cell. So this will be cancelled and this 275 will have remain 175 and this entire column will be cancelled out. So our next steps, our cell move to this area. So since we have a different value 175 and the supply and demand have a different value, so we will put this 175 in this cell and this column and row will be cancelled out, and the next will be in this cell. So our remaining cell is 3 and our supply and demand will be the same, so we will put this 425 in this cell and cancel this column or row. So our demand and supply were satisfied the minimum total transportation cost. So this is the final minimum total transportation cost. So we will be look at this first cell. We have a 4 times 250 plus 3 times 300 plus 7 times 100 plus 12 times 175 plus 3 times 425. So our total cost will be 5,975. This is our total cost for northwest corner method. Balance. Because this is a value of 1,250. So our first steps will be find the lesser value of the cells which have the lesser value. So as you can see, the lesser value will be in this is 3 in D4 and number 3. Since we have different lesser value, so we can be choose which one will be our start or our first process. So I will choose this cell. So since the supply is 425 and the demand is 425, so this cell will be, so copy, allocate the 425 here and canceled out the column and also the row, this row. So this will be 0 and this will be 0. So our next steps, we will be moved to the another lesser value of his duplication, number 3. So as you can see, the demand is 400 and the supply is 550. So we will be copy the demand which is 400. So we will be copy the demand 400. So cancel this 400 and minus subtract the 550 to 400. So it will be remain 150. So this column will be cancelled. So next steps, we will be moved to the next lesser value or the number 4. So these are allocation. Now allocation cells are, so the demand is 250 and the supply is 150. So the lesser value is 150. So we will be cancel this 150 and the remaining will be 0 and subtract this 150. So it remains to 100. Copy 150 in this cell. So this is the next allocation. So next we will be find the so we will be cancel this row. So next we will be find the next least value. So since our least value is 12, so we will be in this area. So 175 plus and this supply is 275. So our demand will be put in this cell. So 175 we will be copy. So cancel this 175 and minus 175. So it will be remain 100. So next, so cancel this column. So next, the last cell which has 13. So since we have satisfied this demand and supply, the remaining value of this demand is 100 and the supply is 100. So we will be put this 100 in this cell. So this will be cancelled out and subtract this 100 remaining, it will be 0 now. So we can see the final occupied cell now. This 150, 400, 100, 175, and 425. So the minimum total transportation cost will be, so the minimum total transportation cost will be equal to, so copy this. So 4 times 150 plus 3 times 400 plus 13 times 100 plus 12 times 175 plus, and the last one will be 3 times 425. So the total cost will be 6,475, and this will be our final total cost in the least cost method. Okay. So our third method will be the Vogel's approximation method. This is our table, supply demand, which is satisfied the need of all transportation problem, and it's a balance problem. This is our row difference, column difference. The first step, we will be identify the lesser value in the cell which the first row. So since the first row will have the lesser value of 3, so we will be subtract this to the next lesser value. So 4 minus 3 we will be number 1. So the next row is the lesser value is 7 and 9. So 9 minus 7 we will be get 2. In the third row, which is 5 minus 3, we will be get 2. In this column for the D1, the first column 4 and 5, so we will be get 1. So the next in the D2, 3 and 7, we will be get 4. In the third column 8 and 12, we will be get 4. And the next or the last column, the 3 and 9, we will be get number 6. So we must find we must identify which has the bigger column or the row value. So since number 6 is our bigger value, so we will be start in this area, in this cell. So finding the least value of this column, so we will be get this number 3. So since the demand and supply which has 425, so we will be copy this supply or demand and cancel this, and it's remain 0. And the entire column will be cancelled out, and this also the row will be cancelled out since the row is satisfy the needs of the demand. So this will be cancelled. So our remaining cells will be this 6 in this area. So our next steps, we will be find same process. So 4 and 3 we will be get 1. 7 and 12 we will be get 5. Since our third row will be cancelled out, so this will be cancelled. So our first row 4 and 13 will be get 9. Our second row we will be get also same number 4, and 8 and 12 will be get 4. And our third and our last column will be cancelled since this column will be cancelled. So we will be identify the largest value. Since the largest value will be seen in the column 1, which is 9. So this will be our first allocation. So we will be identify the least value. So since the number 4 is our least value, so we will be start in this cell. So 250 and 550. So we will be copy this demand since it is a lowest value. So we will be copy this 250. So we will be put this in this cell. So cancel this demand and supply minus 250 will be remain 300, and this column will be cancelled out. So our next steps will be also have a same process. So 3 and 8 we will be get 5, 7 and 12 we will be get 5. So since this row will be cancelled, so this cancel out. So our first row will be cancelled out. So say 3 and 4 we will be get 4. So 8 and 12 we will be get 4. So in the last row, last column will be cancelled out. So we must identify also the biggest value. So since our biggest value, which is number 5, so we can choose which one of this, which two of this value. So I choose the first value, or in the first row. So I will be encircle this number 5. So since our value for this row is 3 is the lesser value for the cell, so I will be put this the next allocation for this cell. So 400 and 300. So since 300 is the lesser, so we will be put this 300 in this cell. So cancel this cell as this 300 or the supply. It will be 0, and the 400 will be minus 300. It will be have remaining 100. So we will be same process. So this column will be cancel. This row will be cancel out. So our first row will be cancelled. 7 and 12, our second row will be, we will be get, it's 5, will be get number 5, because 12 minus 7 is 5. And the last row will be cancelled, and first column will be cancelled, second column will be have 7, third column will be, we will be get 12, and the last column will be cancelled because we cannot have a value to determine this column. So we will be identify the biggest value for this column penalty. So our biggest value is, since 7, 12, and 5, our biggest value now is number 12. So encircle this value. So we will be start in this column in the D3. So since our remaining cells is number 12, so I will put the supply or the demand which has the lesser value. So since I get the demand 175 which has the lesser or least value, so I will put this 175 in this cell. So I will be cancel this 175 and minus subtract this, so 175, and it will be remain to 100. So this row, a column, will be cancelled. So in the last process, we will now have a last cell. So our first row will be cancelled. Our second row will be remaining 7 because this is a remaining cell. So our third row will be cancelled, and our first column will be cancelled. The second column will be number 7 because it is remaining cell, and cancel this too. So since our biggest value is number 7, so I will be circle which two of this. So this is will be satisfy. So this, so since the supply and demand have the remaining 100, so I will be put the 100 in this last cell. So this is our allocation now. So cancel this 100, it will be have 0. So this is our final Vogel's approximation method. So we will be proceed to the minimum transportation cost. So our minimum, so the minimum total transportation cost we will be get 4 times 250 plus 3 times 300 plus 7 times 100 plus 12 times 175 plus 3 times 425. So this is our final total cost for the Vogel's approximation method. So this will be equal to 5,975. So this will be our value for the Vogel's approximation method. And now we will be proceed to the mode method. So our optimality test using mode method. So since the lesser value of the total amount of those three, the northwest corner method, the least cost method, and Vogel's approximation method, and I see that the northwest corner method and the Vogel's corner approximation method will the same total cost, so I will choose the northwest corner method. So this is the cells for the northwest corner method. So our step 1, find UI in VG for all occupied cells, that is IG, where CIG equals UI plus BG. So our occupied cells is 250, 300, 100, 175, and 425. So this, notice that this letter D will be the artificial for the unoccupied cell. So we will put for this for our solution. So our first will be substituting U1 equals, so we will be make U1 equals to 0, and we get C11. So this area C11, the 250, or the value of the cells will be 4. So C11, since our U1 will be 0, so now our V1 will be 4. So V1 equals 4 minus 0 equals 4. So same process. So our third, so C31. So the C31 is the letter D. So our U3 is the value of number 5, and the B1, since our B1 this will be 4, so 5 minus 4 equals 1. And number 4, C34. So that's C34 this. So we will be, since our value of, so in the number 4, C34, so the value of the C34 is this 3. So since our U3 is equal to 1, so 3 minus 1 equals 2. And number 5, C12, this is our C12 for the occupied cell. So our value for U1 equals 0, and the value for B2 equals 3. So 3 minus 0 equals 3. For our C22 and number 6, C22 equals U2 plus B2. Since we have the value of our B2, 3, so the value of our U2 is this, so number 7. So 7 minus 3 equals to 4. So for our last number, C23 equals U2 plus B3. Since our U2 is equal to 4 and the B3 equals to V3 equals to 12. So these are V3. So 12 minus 4 equals to 8. So the table shown will be like this. Our demand supplied for the U1 VG. So our U1 equals to 0, B1 equals 4, B2 equals 3, B3 equals to 8, B4 equals 2, U2 equals 4, U3 equals to 1. For our step 2, find DIG for all unoccupied cells. That is IG, where DIG equals CIG minus UI plus BG. So number 1, so we will be find for unoccupied cells. So since our D13 or our C13 minus U1 plus B3, so since our D13, so this is our D13 for our row 1 and column 3 for D13. So the value for the CIG equals 8. So minus our value for U1 equals so 0 plus value for our V3 equals 8 equals 0. We have the same process for the next row. So D14 equals C14 minus U1 plus B4 equals 11. 11 minus 0 plus 2 equals 9. D21 equals A21 minus U2 plus B1 equals 13. This 13 minus value for our U2 equals 4. Our B1 equals 4 also. So we have the value equals 5. For number 4, D24 equals C24 minus U2 plus B4 equals 9. So this is the value for the CIG for the C24. So number 9. So minus U2 for the value for U2 4 minus the value for our B4 equals 2. So 4 plus 2 equals 9 minus 4 plus 2 equals 3. So for our number 5, D32, so C32 minus U3 plus B2 equals 10. So since this is an unoccupied for the CIG for the D32, so 10 minus U3, the value for U3 is 1 and the value for B2 is 3, so equals 6. So D33 equals C33 minus U3 plus B3 equals 15. So the value for the unoccupied cells for the last one is 15. So minus U3. So U3 equals 1 plus 8 for the B3. So equals 6. So notice that we don't have negative for this step 2 for the unoccupied cells. So our table now will be like this. So this is our final table. So for the 250, 300, 100, 175, 425 for the occupied cells for the northwest corner method for getting the mode. So since all Dij greater than or equal to 0, so the final solution is arrived like this. The minimum total transportation cost 4 times 250 plus 3 times 300 plus 7 times 100 plus 12 times 175 plus 3 times 425 equals 5,975 for our total for our this mode method. So it's the same for the northwest corner method. So since there are no negative in the result, therefore it is not possible to reduce the total cost. So this is the result. So X optimal, X OPT 250, 300, 0. So this will be 0, 0, 0, 100, 175, 0, and 0, 0, and the last one is 425. So our S minimum will equals to 5,975. So this is our final answer for the mode method.
bang 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 bang